Greetings and welcome, friends. We're talking about the law of sines and last night's quest, which was page 316. So I actually recommend whenever you're doing these problems to draw a picture. It gives us kind of like a spatial awareness of what's going on. Probably help us out. So let's see. I've got a 25-degree angle and a 35-degree angle. Actually, question, is that going to mean I have an obtuse triangle? My other angle, these two add up to, let's see, 60. So yeah, the other angle is going to be 130. Right? So that's going to be obtuse. Something like that. I don't know. I'll just draw a triangle like this. So my angle C is going to be very big. Let's see. I'll make this B and this A. I don't know. It doesn't technically matter because, I mean, you can have these flip-flopped and all sorts of things. So the way we perceive these would be all different. And technically, you don't have to have your drawing to scale. But it'd be good to have a sketch just to know what's going on. Let's see, so I've got angle B, I've got side B, I've got angle A. There's two things I could find next. I could find angle C by doing 180 minus those. Or what's the next thing I could find? What's the other one I could find? Side A, right? Because I've got a pair of B and its angle, and I could use law of sines to find the side and angle pair for A there, right? So since I'm looking for a side, what I'm going to do is do A over sine A equals little b over sine of big B. All right, so that's kind of the law of sines setup that we had. There's a bunch of ways you could vary it. You could flip it. You could relate, you know, to C's instead of B's or whatever happened to be convenient at the time. So I'm going to say that A over sine of 25 degrees is equal to 12 over sine of 35 degrees. So to solve this, I'd multiply both sides by the sine of 25, right? So sine 25 degrees and times sine of 25 degrees. So I'm going to get A is 12 times sine 25 over sine of 35. So let's plug this in. Sine of 25 divided by sine 35. And I get A is about 8.84. Okay? So there's the value for A. Now they wanted to solve the entire triangle, so I'm going to have to also find big C and little c. As I said a moment ago, big C I can find. That's the next thing I could do. Doing 180 minus A plus B, the angles there specifically. So angle C, I think we said a moment ago, was going to be 130 degrees. Not that bad. Not that bad. So there's angle C, and now that I know C, I could pair that up with little c in a similar ratio proportion sort of way, where I'll say little c over sine of 130 degrees is equal to, and I'll compare it. Oh, did I do my math wrong? That's definitely a possibility. Yeah, 40 plus, yeah, 6. I knew this added to 60, but yeah, terrible. El más terrible. Yeah, 120. Because yeah, 60 and 120 would add up to be 180. Thank you for the save. So little c over sine of 120 is equal to, and I'll compare it to the b's because that was the stuff that was given me, whereas little a I discovered on my own. So I'll just say equals 12 over sine of 35. And the same exact way we solved, I would multiply both sides by sine 120. Now question, what sign would sine of 120 have? Is that going to be negative? Is sine of 120 degrees a negative value or positive value? How do you know? No, 120 is in the second quadrant, and sine is positive in that quadrant. Now let's see, I wonder if I enter it as sine 120, I got 18.12 for my end result there, which it should be the largest side. And that is what the book says as well. we could actually have rewritten sine 120 as sine of 60, right? The reference angle would be 60 degrees in that case as well if we wanted. So actually, yeah, sine of 120 we could have calculated without a calculator. Sine 35 is probably a little bit bigger than a half, something like that. But anyway, so that's how we could solve that triangle using law of sines. And this is the first time you guys have had this skill to be able to find the dimensions and angles of a non-right triangle. So law of sines is pretty cool. I think it's great stuff. Great stuff. Let's take a look at question 17. It says, if angle A is 37 degrees 20 minutes, so I'm actually going to rewrite that as a decimal, so that's 37.20 divided by 60, that's going to be 1/3, right? Yeah, so 37.3 degrees repeating, is that? Yeah, that makes sense. And angle B is 51 degrees 30 minutes. So if I want to write that as a decimal, 30 is half of 60, so 51.5 degrees. And they said side C is 125, and they specifically want us to find side B. Now, I know angle B, I don't know side B, so I'm definitely going to have that in my setup. I know angle A, I don't know little a. I know side C, I don't know angle C. However, I do have two angles, so my first move, I'm actually going to find angle C, not even using law of sines. I'm just going to do 180 minus the sum of A and B, triangle sum theorem, angle addition postulate, a little bit both. So I'm going to get C is equal to, let's do 37.3 plus 51.5, and do 180 minus that, and I will get 91.17 degrees, we'll call it. Yeah, we'll just round to 2 decimal places. So there's angle C. So this is not a right triangle, it's an obtuse triangle once again. And I'm looking for B, so I've got a pair there, and I finally have another pair for the C's to relate it to using law of sines. So since I'm looking for a side dimension, I'm going to put the sides up top instead of the angles. So B over sine of 51.5 degrees should equal 125 over sine of 91.17. There we go. And so I would just solve by multiplying both sides by sine of 51.5. Did you do the same thing and it didn't work out? So let's see. Let's plug this in the calculator. So I'm going to plug in 125 times the sine of, what was it, 51.5, close parentheses, divide by the sine of, what was angle C? 91.17. Sounds like a radio station. Close parentheses and enter, and I got 97.84, and that is right there what I'm looking for. 97.85 if I round up. So I found what I was looking for. And you can always check the reasonability of your solutions. Notice that side C was pretty large and is opposite the largest angle of the three. So I was expecting side B to be less than this value because it couldn't be as large as the one opposite the largest angle. In fact, I suspect that this would be the middle side in terms of dimension because angle B is the middle angle. So it's just right, like Goldilocks and the Three Bears. So thanks for watching, friends. Have a great day. Bye-bye.